Welcome back to The Explainer. Today, we're zeroing in on a massive global sector, one that is literally the foundation of our modern world, but brings along a really heavy, often completely unseen burden. We're going to unpack exactly how we make the invisible footprint of the construction materials sector visible, specifically through some incredibly strict data accounting. So if you want to know how regulators and investors are measuring the true environmental cost of heavy industry, well, you are definitely in the right place.
Here is our quick agenda for today. We'll start with the invisible footprint, then move to enter SASB standards, look at the air quality mandate, dive deep into quantifying the 7 pollutants, and finally, wrap up with the true cost of emissions.
Section 1. The industry's invisible footprint. Okay, so we really have to start by wrapping our heads around the sheer scale of the construction materials industry. When we talk about this sector, we're talking about physical, massive products. Think of the essentials: cement, aggregates, glass, roofing materials. These companies are operating global networks of quarries, mining crushed stone, sand, and gravel. But while the products themselves are super heavy and tangible, the actual production processes, the intense on-site fuel combustion and those complex chemical reactions, they generate a massive, largely invisible environmental footprint.
And that's really the core problem here. It's a crazy contrast. On one hand, you've got these highly visible outputs, right? The cement and the glass that we literally use to build our cities. But on the other hand, you have the invisible outputs, hazardous chemicals and criteria air pollutants. We're building these tangible materials for society, but at the exact same time releasing intangible, highly localized health hazards straight into the air.
Section 2. Enter the SASB standards.
So you might be wondering, how do we make the invisible visible? Well, we need a regulatory framework that essentially acts as a lens. And that lens is the SASB standards. Now, under the stewardship of the International Sustainability Standards Board, which is part of the IFRS Foundation, that connection gives these standards immense authoritative credibility around the globe. Specifically, if we look at the standard for the extractives and minerals processing sector, this framework mandates absolute transparency. It demands that entities measure their impacts in a highly standardized, rigid way.
But why does SASB care so much about air quality? Well, tracking these emissions isn't just some feel-good environmental exercise. It is a fundamental financial metric. Notice the specific focus here on cash flows. SASB standards are specifically designed to surface information that is reasonably expected to affect an entity's cash flows, its access to finance, or its cost of capital. So, at the end of the day, this is absolutely about the bottom line.
Section 3. The air quality mandate.
Let's drill down into the specific regulatory mandate regarding what this sector is actually pumping into the air. If you look under the SASB Construction Material Standard, you'll find metric EMCM120A1. This metric flat out demands that entities disclose their direct air emissions resulting from all of their activities. And guys, it doesn't leave any wiggle room. The scope includes stationary sources like massive production facilities and kilns, right down to mobile sources like heavy transportation fleets. Bottom line, if your operation released it, you absolutely must disclose it.
Section 4. Quantifying the 7 pollutants.
Okay, let's get into the data visualization core of our explainer. We're going to break down these complex chemical metrics and see exactly what's required. SASB makes entities actively quantify and report on what we can basically call the dirty 7. We're talking oxides of nitrogen, oxides of sulfur, particulate matter, dioxins and furans, volatile organic compounds, polycyclic aromatic hydrocarbons, and heavy metals. You can't just slap a generic pollution number on a report anymore. No way. You have to break it all the way out into these 7 precise categories.
And how exactly is all of this reported? In metric tons. I really want to emphasize the sheer weight of air here. You're taking invisible floating gases and microscopic particles and forcing companies to literally weigh them. To put that into perspective, just a single metric ton of a gas like CO2 would fill up an entire 2-story house. Now imagine weighing out tons of highly toxic compounds. It's just an incredibly powerful way to standardize data, forcing the measurement of air pollution into physical metric tons per pollutant.
Now, the accounting rules for organizing this metric tonnage are incredibly rigid. That's to ensure perfect comparability across the whole industry. Notice the strict scope exclusions here. SASB doesn't just casually say, report NOx. It specifies that NOx includes NO and NO2, but explicitly excludes N2O. For SOx, it has to include SO2 and SO3. And for heavy metals, the standard hones in specifically on lead, mercury, and cadmium. There's absolutely no guessing game here.
Let's do a quick deep dive and define the most complex of these pollutants, just so we truly understand what is being weighed out in these metric tons. Starting with PM10. This represents airborne, finely divided solid or liquid material with an aerodynamic diameter less than or equal to 10 micrometers. For a little context, a single grain of fine beach sand is about 90 micrometers. So, PM10 is a tiny fraction of that size. It's literally microscopic dust from quarrying and crushing stone that's so small it completely bypasses our body's natural defenses when we inhale it.
Next up, we've got VOCs, or volatile organic compounds. SASB defines these as carbon compounds that actively participate in atmospheric photochemical reactions. So, in plain English, these are the chemicals that react with sunlight to create harmful ozone and smog. And notice the strict accounting popping up again. Methane and carbon monoxide are specifically excluded from this metric. That ensures investors are looking at a very specific reactive type of atmospheric hazard.
Then there are PAHs, polycyclic aromatic hydrocarbons. These are mostly generated by the incomplete combustion, or pyrolysis, of organic material. Now, in an industry that relies heavily on intense high-heat kilns that are often burning alternative fuels like scrap tires, plastics, or waste oil, PAHs are a massive indicator. Basically, if the fuel doesn't burn completely efficiently, these hazardous compounds get released. That makes them a crucial metric for emissions control.
And of course, we absolutely cannot forget heavy metals. Now, the actual quantities here might be smaller compared to something like particulate matter, but they are highly, highly concerning. The SAS standard explicitly requires the tracking of highly toxic elements, specifically lead, mercury, and cadmium. These elements don't just magically disappear. They settle into local environments, and they have severe, well-documented neurological and developmental health impacts if they aren't properly scrubbed from those exhaust gases.
Finally, dioxins and furans. This is probably the most chemically specific mandate of the whole bunch. Entities actually have to calculate the sum of 17 distinct congeners, which are related chemical structures, of polychlorinated dibenzodioxins and dibenzofurans that contain chlorine. I know. It's a mouthful. But this level of meticulous, granular accounting proves something important. Entities cannot simply guess their environmental impact anymore. They are required to have deep, continuous, and highly sophisticated chemical monitoring capabilities.
Section 5. The true cost of emissions.
So, let's tie all of this massive data gathering back together. Why does breaking down these metric tons actually matter to an investor? Well, we track the dirty 7 because they represent severe operational risks. These invisible gases lead to very visible, localized human health issues and environmental damage. But looking at it from a pure business perspective, failing to control these 7 pollutants leads directly to skyrocketing compliance costs, forced capital expenditures like having to retrofit older plants, and some really severe regulatory and legal penalties.
As the SASB Air Quality Topic Summary explicitly warns, the financial impacts of ignoring these emissions are profound. Think about it. If a cement plant is out there emitting excessive metric tons of SOx or heavy metals, that isn't just an environmental failure. It is a massive financial vulnerability, just waiting to be triggered by the next wave of environmental laws or local penalties.
Which brings us to our final thought. The SASB standards actually note that active management of this issue through technological and process improvements can yield real operational efficiencies. So I want to leave you with a question to ponder. How will technological innovations designed to minimize these 7 pollutants transform from a simple compliance cost into a long-term competitive advantage for the smartest companies in the sector? Thanks so much for joining me on The Explainer today, and keep learning.